All right, in this video, I'm going to continue to go over exercise problems. Okay, so in Pandas. So now, here we're gonna deal with the wind data. Okay, so let's see. Okay, let's see introduction. So the data have been modified to contain some missing values and identified by NAN. The using pandas should make this exercise easier, in particular for the bonus question. So, but yeah, so I just delete the bonus questions. So just ignore that. Okay, you should be able to perform all of these operator without using for loop or other looping construct. So okay, so we have to take a look at the data structure. Okay, first. So data structure, the data win that data has the following data structure. You see the year, month, look at the column label, year, month, day, and then RPT, VAL, RS. See, 0, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. The column labels. Okay, and and then let's see. Okay, so the first three columns are year, month, day, and then the remaining 12 columns are average wind speed in knots at 12 occasions, uh, all in on that day. So except for the first three columns, the remaining columns are average wind speed in knots at 12 locations. Okay, I think um yeah. So okay, so step one, we have to import the pandas, right? And then import, and then I forgot to add a step two to the print out the today's date, but it's okay. Step three, assign it to a variable called the data and replace the first three columns by a proper date time index. We haven't, the deal with the data time many times, right? So I believe you know how to do it, but let's see. First one. So yeah, we PD read table, okay, the wind data. Okay, this is not CSV file, so don't use PD, read the CSV. Okay, instead of that, we use a read underscore a table. And then look at in the when you look at the open the data file using text editor or just other editor software, you see each column is separated by spaces. So then it means that each columns are separated by white spaces. Then we use that command backslash s plus. So backslash s plus, as you can see, that means one or more white space characters. Okay, and then the see parse underscore dates 0, 1, 2, 3. It means that we're gonna use not sorry. So we're gonna the combine three columns attribute, and then consider that as the year, month, day. I mean the daytime. Okay, so when you can see that, you see uh, the first three columns are combined, and then we got the date, right? So 2061, January 1st. But look at this, 2061. It doesn't make sense. This year 2020, right? So 2061, it doesn't make sense. I think that's a mistake, the typo, right? It should be maybe 1961, right? So I think, yeah, so this is step four, year 2061. Yeah, it doesn't make sense. So do we really have data from this year? Yeah, definitely no. So create a function to fix it, 1961, right? Okay. And then we look at this. We got just only that error, type of error in just 1961 or 19 more than 90, greater than 1961. Just we need to figure out that. So let's look at this. I mean, let's see. For example, we need to figure out, let's see, date and info. Okay. Then how many columns here? So index is 6,574. So let me see, 100 to 200. ahead. Okay. Give me a second. Sorry. So I use let's see, 100 C still here. Okay, so 500 maybe, or 700. Yeah, it's just even we got the for the 1962 here. We see we got this 2062. It should be changed to fixed to 1962, right? So anyway, let me change this one. All right. So here, what are you gonna do? The first one we need to define a function, right? Okay. So define fix. Okay. Century and x is input variable. Okay. So year is equal to x dot year. Okay. So what's the input? Input variable gonna be the attribute in a first column label. Okay, first column. So actually it's zeroth column, right? So x dot year. Oh, excuse me. So that year and then minus 100. Right? Okay. So now then if x dot year is greater than 19, we can't just what the subtract 100 every single the data value, every single the row, right? I mean all the attribute in the first column in every single row. Okay, so because when you look at the when you tail, then you see 1978. That's a right number, right? 1978 is the right number. So if we just let me see here. So if it's x dot year is greater than 1978, okay, right? Then let's see. Okay, if here and then we subtract 100 from the x dot year. X dot year will return the year in the attribute in first column. Okay, for example, let's see, right? Then what? 2061. The x dot year. I mean, if x is 2061 and January 1st, the x dot year will return the 2061. Okay, so 2061 is greater than 1978. So then we're gonna subtract 100 from 2061. So you're gonna get 1961. This makes sense. And then else, then we do nothing. We just year gonna be just x dot year. Okay. Let's see now, and then return daytime, the date, and the year, and the x, and the month, and the x, and the day. Okay. So this is a function that fix what the you know the year which is greater than which is which doesn't make sense, such as 2061 to 1961. Okay, for example. So now and then we apply the function fixed entry on the column and replace the values to the right ones. Okay, so data is y year, month, day. Okay, that will be replaced by data. Okay, year, month, day. Dot apply. This is how to apply the function and column of data in the data frame. Okay, excuse me. So apply and then fix entry. Okay, and we see the data head. You see it's fixed, right? Okay. So now then step 5. Set the right date dates as index. So we want to set the dates as first column as index. So now then not only just the set the first column as the index, we have to change the data type. See, look at this. Let's see. Look at the data type of first column. Zeros column. Sorry, zeros column. It's an object, right? It means a string. So we have to change the data type of the zeros column as date times, right? Date times 64. So we have to do both. Okay. So now the data. First, we're gonna transform the zeros column to date type what? Date type 64. Okay. So data and year data is equal to uh, we're gonna use package command in the package pandas to date time, okay, and data, okay, pd dot and then two underscore date time. That's command to change to set the column data type to date time. Okay, and then we what set. Oops, we just changed the we set the zeros column as index. Okay. And then we see that then we see the data dot head. Okay, let's see. Oh yeah, I made a typo. Set data. Let's see. Mm, okay. So yeah, let me find out the typo. Okay, so give me a second. So it should be M O, right? Not N. Okay, sorry, it's a typo. Okay, now we change the what data type of the zeros column, year, month, day to date times 64, and then set it to what index. Step 6, compute how many values are missing for each location over the entire record. Um, okay, so we'll find out total number of missing values, right? Then we use this one, data. I covered this one, and when I cover the basic, I mean cheat sheet in pandas. Okay, but just we use an is and null and then so. So is null. This one gonna find out all of the attribute, okay, whose value is just missing. Values are missing. Okay, and then we take a sum. Okay, you see that for each column label, we can see how many the attributes, excuse me, how many values are missing. Okay, for each column. The compute how many non-missing values there are in total. Okay, then this first one, data and then shape 0. First one, we have to figure out number of columns minus the number of missing values for each location, right? So Dave share 0 will give us what? See that? Dave shape 0, this will give us the total number of rows, right? Excuse me. Okay, so 0, because we know 0 direction, which is the row directions, right? And then 1 means axis 1, 1 axis means column direction. Excuse me. So now here in the minus, okay, then we find the data is null and sum. Okay. So now what? Look at this. Data type shape and then bracket 0. This one is give what we know that that returns a single number, right? 6 6,574. Single number minus, and then data dot is null dot sum. They give us, we see that here? They give us array, right? I mean, the this give us the what the value list of values for each, for each column, right? Then this one, the when you do subtract, then the Python gonna automatically make the copy data type shape 0, which is 6,574, as a list of the that number to match the size with the data that is null dot sum. Okay, so if you do this, you see, and then you're gonna get the what um, the non-missing values for each column. Okay. Step 8, calculate the mean wind speed of the wind speed. Okay, mean winds, find the mean wind speed over all the locations and all the times. So yeah, so we just use data, and then for the field, we have to, to compute the mean, we have to deal with the missing value first, right? So we're gonna fill NA and 0, which means that fill 0, I mean all for the all the missing data filled with 0. Okay, and then values, and then see to calculate the mean wind speed for not for each column, but all the locations and all the times. Then we have to flatten the data frame as one single array of the kind of, we just the change the dimension of the data to one dimension array. Okay, it's kind of serious. And then we're gonna find out me to do that, to make the the two, this is two-dimensional data frame, right? To the data frame to the series, we use this flatten. And then me MEAN, sorry. Okay, so the now step 9, create a data frame called LOC and so underscore and then stacks, and calculate the mean, maximum mean, and standard deviations, okay, at each location over all the days. So look at the solution right there. So we want to find out uh, the basic inferential statistics, okay, for each column, right? So we know how to do it. So just what use the describe, right? Okay. Um, Now, but we cannot. When the problem asks us to create the new data frame, okay, LOC, you see, stack, okay. Uh, do we calculate? We're gonna calculate the data that describe, right? Okay, and then you see, and then look at the solution. There is now what 25%, 75% percentile. So in this case, to get the only 50% percentile means median, right? So to get rid of the percentile, we use this one. Percentile is equal to empty. Okay, I mean, so then LOC and state with this. Okay. Now step 10. Create a data frame called the day stat and calculate the minimum, maximum, mean, and then standard deviation. Okay. So you see minimum, maximum, minimum wind speed and the standard deviation of the wind speed across all the locations at each day. Now you see the difference between two problems, step 9 and step 10. step 9 is what? So infer statistic over all the days. So step 10 is for each day, right? So first one, let's see. Then, yeah, so I think we need to figure out, we need to calculate the mean, maximum, median, standard deviation manually, what that means. First of all, let me DA1 uh, create this stack. DATS stack is PD, and then data frame. Okay. So we declare the new variable, new data frame, and then we calculate the stack. Okay, the minimum. Minimum is equal to data, and then minimum, and then axis is 1, right? For each day means that what? We're gonna find out minimum of all of the locations at each day. So we're gonna find a minimum along the what column directions. So axis equals 1. Okay. So now and then day and stack, the maximum day is equal to then data dot maximum. Okay. And the axis is equal to 1. Okay. So now you can find the standard deviations in the mean, right? So that's the let me leave this one as your exercise. Okay. So now the day and the stack finally and the head. Sorry, it's typo. Okay. So we got just minimum. I got just minimum maximum, but please work the uh finding maximum and the mean and standard deviation by yourself. Okay. Step 11. Find the average wind speed of January for each location. So, okay. So treat January 1961 and January 1962 both as January. So first, what are you gonna do? We have to find out what. Give me a second. So, mm, so it means that we have to find out the all of the rows whose index. I mean, whose the date is January. Okay, January. Whose month is January? The value month is January, right? So the collecting them, and then we're gonna calculate. We're gonna calculate the average wind speed for each column. Okay. So first one, let's collect the all of the row whose value month is January. Okay, data dot index, because now this is what the date is index, right? The index dot and the month, because keep in mind is we have changed what the data type of index as date times 64. So month, you can use this month. That is equal to 1. I mean, the month is equal to 1. Okay. Let's see this one. Now you see, you click here. I just enter that command. Okay. Then what we got, let's see. All the rows, look at the index of all of rows. So January, look at the month in the index of every single, all of the rows. You see January, right? So now we're gonna calculate the mean. So now next one, step 12. The downsample the record to a yearly frequency for each location. Um, uh, okay. So first one then, well, you see yearly frequency, then we have to combine all the data for each year, right? So now then to do that, each year, and then what? yeah, each year. Then to do that, we need to grouping by year, and then we calculate the mean. Okay. So now then data, we use what? Guess what? Group by, right? Group by, and then data. What's the difference between step 12 and 11, by the way? Step 11, um, well, we just find out, we just find the, what can I say? The, we just extract the kind of, we just select the rows having the same pattern of value. Okay, step 12 is not just extract, it's a reorganize, it's grouping. That's what we use a group by. Okay, the data dot index to period, we use the data dot index a period, and then annual. The capital letter A means annually. What about capital M? Monthly. What about capital D? Daily. Okay, keep in mind this. The A, capital A means annually. Okay, and then mean. Oh, this typo. Okay, now we see. So we can see being for each column label for each year. Okay. Well, look at this. I don't know what that maybe you see CLA. I don't know what that what city means in this one, but for this column, the let me choose other column. Okay, so one second. Um, let's see ML, maybe Malibu. I don't know. Well, you see 16, 17 right there, right? 17.13. I think this is 1967. In, it has the maximum, the quite strong, the wind speed, right? In average, right? But to find out this, we use without use this, we just find max. So you can figure out the maximum for each year or minimum or yeah mean. Don't just the follow what I'm doing. Okay. So once we figure out this command, okay, try to apply this command in other data source or try to tweak the command to get the other result. Okay, like this. Now, what about if we will find out mean? Wind speed for each column for each year. Okay. So now next one, step 13. Downsample the record to a monthly frequency for each location. So see monthly, monthly, then what? I told you how to do that. It's pretty much the same, similar to that command. Okay, so let me skip it. So step 13, just try to do by yourself. And then now step 14, okay, frequency weekly. Yeah, I'm sure you can figure it out. Okay, skip it. Step 15, calculate the mean, maximum mean, wind speed, standard deviation of wind speed across all locations for each week. Yeah, in this case, we use this one. First one, when we use a resample, instead of using group by, let me use a resample. So first here, I'm going to resample data to the week and use the function. So what that means, say we weekly is equal to data dot sample w dot, and then so now then what data dot resample w, we're gonna what do what give me a second. So we'll see, give me a second. So resample w is similar to group by. Okay, so they're gonna grouping the data for each week. Okay, the w, and then we're gonna do aggregate agz, and then minimum, and the maximum, and the mean, and then standard deviation. Okay. And then we're gonna slice it for the first 52 weeks and locations. Okay, so let's see, LOC, okay, and then weekly, weekly, that index, 1 through, and then RPT, 2, maybe, okay. Second, let's see, and then head. So give me a second. Okay, so here, let me explain what that means. So resampling. Resample is nothing but group by, but excuse me. So let me figure out. Okay, so when you do this, just enter that command, and then just look at the head right there. So now, yeah, we don't have to uh, turn head. Just type the weekly, then you see. Then look at the row, each row. So 1961 January 1st, and then 1961 January 8th. You see. So this one gives us what the uh, January 1st, and then January 8th, January 15th, January 22. So they calculate the minimum maximum mean the mean and standard deviation. But definitely, is look at the first row. So this is the all the attributes in the first row. It's just a what data value for each column. Okay, it's not the actual minimum, maximum, mean, and standard deviation because this is 1961 January 1st. This is one day, not the what inference statistic over week. So we have to exclude that data, that row. Okay, so that's why we get the missing value in the standard deviation. So that's why we're here. Then you see the weekly dot index 1 through 53. So we then what? So this is actually first week means that what? Zeroth row, right? So 1 through 53 means that 53, where that comes from? 53 is what? Actually, it's 365. 1 year is what? 53 weeks, right? So then now then, give me a second. But the actually in Python, the index starts from zero, right? So 0 to 53, right? Actually, what 0 to 53 means 54, right? So then 1 means that what we're gonna drop the zeroth row. Okay, keep in mind this. All right. So I mean, or if you don't get it, then just look at this weekly and info. Okay. So now then, let me see entry type. Give me a second. 940. So give me a second. Weekly. Okay, so oops. All right. So 1 year is 53 weeks. Okay, so we have to exclude the 0th week. Sorry. Okay. And the problem says that what we want to find out, so the find out the what calculate the minimum, maximum, mean, and wind speed and standard deviation for the just first 52 weeks. That's why. Okay, that's why we drop the zeros week, and then n to 53. I told you the n number right there. And then in Python, the end index does not include. So 1 through 52 actually. So this is actually 52 weeks. Okay. So now we're gonna get this, but okay, you don't want to get the you don't want to print all the rows. You just say okay. All right. So yeah, the next video I'm gonna continue cover the exercise 14. Okay. So stop here.